So again, this is our warm-up, and we're working through this. And I have how many people like Dr. Pepper? How many people like Coke? There is probably going to be some overlap in there as well. All right, there's 35 people there, 22, 19, and then the 3. So where would you start on this one? Putting 3. 3 is the one that we want to put. Where does 3 go? Outside the circles, but inside the parentheses. So I have that there. Now, this is that combined events that we've been discussing. The probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. All right? So from this equation right here, what do we know right now? What could we fill in? It's 35 the probability A?
It's the one at the very end. How do you say it?
This one right here?
Yes.
Not quite. You're close. There's going to be a little adjustment we're going to make on that one. Okay. 22 is probability A. That's one of the events. 19 would be the other event. It's asking me to know how many of them are both, which is that one right there. So they must have given me this one here. That's 32. It's not quite 35. 35 is everybody, correct? But there are 3 people that don't like Coke or Dr. Pepper. All right, so that leaves me 32 people that like that in some version. Either they like one or the other, or they may like both. Okay? So we'll add the 22 and the 19 together. I believe that's 41 equals 32 minus X, and I'll subtract the 41 from both sides. When I do that, I get negative 9 is equal to negative X, so therefore X is equal to 9. So I've answered this question here. How many people like both? There are 9. Okay? You should be able to go fill in the rest of the Venn diagram. What number goes in here with the Coke? 10, because they have to add it to be 19. What number goes in here with the Dr. Pepper? 13, because they have to add up to be the 22. Now, all that should add up to be 35. Okay? Now, let's answer the last question. How many people like Dr. Pepper given that they like Coke? Say again? 9 over 19. That is correct. 9 over 19. All right? We talked yesterday about givens and conditional probability. Given that they like Coke, if I'm talking about that, given that they like Coke, I'm only looking at the people in this circle right there. There are 19 people in that circle. How many of those 19 like Dr. Pepper? Well, the 9 that like both, all right? So 9 out of 19.
Okay, so like yesterday when we were doing one problem, and it was like just asking for like a certain amount of people. You
Yes.
said that it's like not probability. So,
Yes.
like, could you also technically answer this as just 9, or does
I
that
guess
have
you
to be-
could, because I didn't ask probability on that one. So
Okay.
yeah.
Cool.
Yeah. Yeah. So probably should have written that as a probability question, but yeah, you're right. Okay. All right. All right. So let's go back in our note packet today. We have talked about Venn diagrams. We have talked about sample space diagrams. And the last thing that's here is probability tree diagrams. All right. It's another very helpful tool as we're trying to find the probabilities. All right. The tree diagrams, I think, I like them more than sample space diagrams because they actually show the sample space and they kind of give me a little bit more clarity into what's going on. All right, so I'm going to give you just a little bit of a moment and I want you to kind of read that problem and we're going to discuss it. All right. What are some key things that you read from here that are going to be important for us? He's going to take 2 shots. Okay, so that's important. So we're going to draw that. They're independent. So if he lines up to take the shot with his bow and arrow, all right, and he looks to see what happens, and he kind of takes a step back, and then he lines up again, takes it again, all right? So one shot's not dependent on the other shot. So here's what we'll do. He lines up, and he takes a shot. I made 2 branches. Why? What's the results of the first shot? Okay, 0.8 is the probability. 0.2 is the other probability, but what's happening with the 0.8?
There's a chance it hits.
He hits the bullseye, and the other part is he misses. All right, I just put an H and an M for hits and miss. Okay, so he lines up, he takes the first shot, there's the first shot. He lines up the second shot. When he takes the second shot, same thing. He's got a chance to hit and miss, chance to hit and miss. What are my probabilities that go here? 0.8 and 0.2, they're the same because they're independent. All right? So if it's independent, the probabilities are not changing. Okay? So there is my probability tree. How many different paths do I have on this tree? 4 different paths. I could go here, I could go hit, I could go hit miss, I could go miss hit, and I could go miss. That's actually my sample space. All right? If I were looking at, I took the first shot, there was 2 things that could happen. I took the second shot, there's 2 things that could happen. 2 times 2 is 4. Here is my sample space. Okay? Now, the question asks this. What is the probability that he hits 2 bullseyes? How many paths lead me to that result?
1.
Just 1 path, all right? The 1 path that leads me there is this right here, okay? So that path leads me to hit, 2 hits, all right? I'm going to multiply down the tree, all right? So I'm going to go 0.8 times 0.8, and that gives me 0.64. That is the probability that I get 2 hits, 2 bullseyes. Okay? What is the probability that I get only 1 bullseye? Well, how can I do that? How many paths?
2.
There's 2 paths that take me to 1 hit. I can hit and then miss, or I can miss and then hit. So there's 2 paths that take me to this result. All right? So I'm going to multiply 0.8 times 0.2. That's going to give me 0.16. Now, what's nice about the second path?
It's the same.
It's the same, all right? And so it's also 0.16. Now here's what happens. I multiply down the tree, but if there's several paths that give me there, I add the paths together. So 0.16 plus 0.16 gives me 0.32. So I have a 64% chance of hitting both. He has a 32% chance of hitting one of them, all right? So I go to the last question here. It says, what's the probability that he hits at least 1? How many passes take me to at least 1? The 3 passes that we've already done, correct?
So would you add the 0.64?
I can add the 0.64 and the 0.32. That's correct, okay? So this would be 0.96. So he's got a 96% chance of hitting at least 1 bullseye. Okay? Could you find that another way? How did we talk about yesterday?
Just the 2 misses
Yeah.
subtracted by 1.
We just don't want that path, right? We don't want 0.2 times 0.2. So 0.2 times 0.2 is 0.04. So there's 4% chance that he doesn't hit one at all. Well, 100 minus 4% gives me the 0.96. Okay? Now, this is not a huge probability tree, but if I had one that had like 8 different outcomes, I might not want to add all 7 of them together. I might want to just find that 1 and subtract it. Okay? All right. Let's turn the page. Give you a chance to read this one real quick, and then we'll talk through it.
Oh, this looks scary. Scary.
All right, here we go. We did a problem similar to this the other day. But on this one, I have one container, and I'm selecting 2 draws out of that. So I'm gonna reach in there, I'm gonna grab a ball out. Maybe this is like Christmas time or whatever, you got your Christmas ornaments or whatever, red and green. So I reach in there and grab one, alright? And then I'm gonna reach in there and grab a second one. So that's what I'm gonna do. Okay. Is this independent probability or dependent probability? Dependent, because when I reach in there and grab something out,
The next one.
does my probability change?
Yes.
They change now, okay? So this is a dependent situation. So if I were to go in there and draw one ornament or one ball out, I could get a red or I could get a green. Okay? What is the probability of getting a red?
5 out of 11.
6 out of.
I think you did green.
6 out of 11.
So red is 6 out of 11. And this one is 5 out of 11. By the way, every time the probability tree splits, it adds to be one whole. It adds to be 100%. So 6 out of 11 and 5 out of 11 add together for 11 out of 11, which is one whole. If you were to have 3 different branches on your tree, all 3 of those probabilities would have to add up to be 1. Okay? We don't have that situation here. We just have it split twice. Okay? Now, I grab one of these out. I'm holding it in my hand. And I'm going to reach in and I'm going to grab a second one. Alright? I could get a red or a green again. Now, if I reach in and I grab a red and the red is in my hand right now, what is the probability of getting a red on the second pull?
5 out of 11.
5 out of 10. There's one less ball in the container, and there's one less red one. So there's 5 red out of 10 total. I didn't get any green ones out, so there's still 5 green ones, and there's still 10 balls. What is 5 tenths plus 5 tenths?
1.
1 whole. Alright? So each time it branches, it's got to add to be 1 whole. Alright? If I reach in there and I grab a green, so I have a green in my hand, what would be the probability of getting a red?
Or no,
5 out of 10.
6 out of 10. There's all 6 red ones still in there. I have a green one in my hand. There's 6 there.
I get it.
Okay?
I understand it now.
Third.
And if I reach in and grab the green one, then there's one less green one, so there's only 4 green ones now. Okay? Questions about this before we begin? With dependent, what do you recognize about all the probabilities? They're changing. They're different. Okay? Alright. Now, on this one, I'm going to give you just a little bit of time. I want you to see if you can find this. What is the probability that at least one green is chosen? So find the probability. Use your calculator if you need to. Find the probability that one green is chosen. Yeah, I picked 2, and I want at least 1 green.
Oh, only from picking 2.
Mhm.
I was
I'm about to do this in common sense way. It would be 1 out of 11. Yeah.
You're gonna need a.
All right.
You're gonna be done.
Here we go. I want at least 1 green chosen. How many pass take me to 1 green chosen? 3 pass. I could go red, green. I'd have at least 1 green. I could go green, red. I'd have at least 1 green. Or I could go green, green, and I'd have at least 1 green. So I need to do all 3 of those pass. Well, if I were to do 6 11ths times 5 tenths, 6 times 3 or 6 times 5 is 30, and 10 times 11 is 1/10. Okay? Now, you could simplify that pretty easily. I could get rid of the zeros, correct? So we could say 3 out of 11. Right? If I do the green red, it's the same thing. 5 and 6, so it's also 3 out of 11. And then the last one, the green green, is 5 times 4, which would be 20. So that would be 2 out of 11. Huh? I'm multiplying. Okay? And so, but because they're all gonna have a 0 here, they all have a 0 there, then I can just make them all 11s. Okay? So I got 3 plus 3 is 6, plus 2 is 8. So I have 8 out of 11.
Coach Russ,
Yes.
can you show the last one again?
Say that again.
The green.
The green would be 20 out of 110. So that's 20 out of 110 or 2 11s. Okay? Now, you could do this a different way. What's the only option that I don't want? I don't want a red. A red would be 3 out of 11s. And so if I subtracted the 3 out of 11s, that would give me the 8 out of 11s as well. Okay? I can do that either way. Now, part B of this. They like to do this question when they're talking about probability. They ask me to find something probability-wise. Then they say this: what is the probability that red is picked on the first pick, given that you have at least one green chosen? All right? Well, what's the probability that I have at least one green chosen? What we just found. So our answer from A is our given on this one. If I were to write this, find the probability that a red is chosen first, given that there's a green, then we would do the probability of red first and green over the probability of green. So that was our equation from yesterday. Well, the probability of green is this that we just found. The probability that we got at least one green. So the 8 out of 11s goes on bottom. What is the probability that I got a red first and a green? How many paths is that? That's just that first path. Probability of a red first and then I have to have a green. That's the only path that takes me there. Okay? So my sample space is this. I'm looking at these 3 outcomes, but I want that one out of the 3 outcomes. Okay? So I've shrunk this from 4 different outcomes to 3 different outcomes, because I'm saying I have to have at least a green. Right? The 3 out of 11s is the one that I want. The nice thing about that complex fraction is what? The 11s cancel, so it's just 3 out of 8. Okay? Questions about that one before we move on? Now, could we have asked a lot of different questions about this one? Sure. Okay. All right, last problem for the day. Give you a chance to read it, and we're going to finish here. Some of you are still copying, giving you a little bit more time here. All right, here you go. Read the next one. Do I have any tennis players in here?
Yes.
No.
I'm more of a pebble person.
I don't think I do.
I'm gonna be.
I play tennis. I want to see.
All right, I need you to read.
Everybody's so.
JV wins.
There were literally the trees on that paper that we were reading about.
Astute observation. All right, here we go. Let's discuss this. All right, so tennis. All right, I think they did a pretty decent job explaining kind of how to win a point here. All right, so the first thing in tennis that you do is you serve. All right, if it's your serve, you're going to serve. And so when I serve, what could happen when I serve?
It's in or out.
It's in or out. Okay, I can serve a good serve and it be in, or I can serve a bad serve and it's out. Okay, that's the first thing that could happen. Now, it tells me here the success at getting his first serve in is 3 out of 5. So this would be 3 out of 5 right there of getting it in.
So the other one would be 2.
So the other one would be 2 out of 5 of getting it out. Okay? Everybody okay with that? So we serve. If it's in, you play back and forth. All right? When you do that, you're either going to win the point or you're going to lose the point. Okay? So you get the serve in, you play. You're going to win or you're going to lose. What's the probability of winning? 0.75. What's the probability of losing? 0.25. Again, because all these have to add up to be one whole. All right? Now, some of you might like tennis because if you get it out, do you lose? No, you get a redo. You get a second serve. All right? So if you hit it out, you get a second serve. And so that serve could be in or out. Okay? What's it say here?
The second serve in is 3 out of 4.
3 out of 4, which means out is
1 out of 4.
1 out of 4. Okay? Now, here's the thing. If you go out, out, if you serve it out and then serve it out again, that's an automatic L. All right? Because it told me it was 3/4.
Oh.
It specifically told me that. Okay? Because if not, if they were all independent, okay, we'll talk about it more in a second. Okay? All right. Now, I've got one last little thing to draw on here. It says this: if I serve out and then I serve in, then we play. All right. And when we play, I can win or I can lose that point. The probability of winning is 0.45.
Never ending. Like, when does it stop?
When we stop.
Okay, that makes sense.
When
Right
you win
there.
or lose, that's when it stops.
It stops right there. All right, so that's it. Now, it's not a nice symmetrical probability tree, right? But it gives me a lot of all the information there. Now, here's the thing.
Where did you get 0.45 and 0.5?
And told me.
It said it.
It's
Where?
When he uses his second serve, there's a 0.45 chance of winning
Oh,
the point.
okay, sorry.
Yep. All right. Now, let's do this. Couple of things I want you to see here. I don't know that I have all your attention. How many different paths are there in this tree?
1, 2, 1.
There's 5 different paths. That's correct.
4, I see.
We have 1,
Mhm,
2,
mhm.
3, 4, and 5. There's 5 different paths. How many of them lead to a win?
1,
2.
2.
2 of them lead to a win.
2 out of 5.
3 of them lead to a loss. Okay? And so if we were just looking at that, we could do that. Now, why do you think these serve probabilities are different?
Because if you miss the first time, it's probably an accident, but if you miss the second time.
Okay?
Well, it's like when you, with the first serve, you want to do better. So you have to like, you want to hit it harder.
Okay.
And then the second one, you have to be more under.
So if I know I get another chance, correct?
The second one
If-
you actually try.
Yeah, if I know I'm gonna get another chance, I might hit the first one as hard as I can.
Bam.
Okay? I hit it as hard as I can, which means I'm probably gonna miss it more. Alright? But then I know that I have to get this one in, so I might hit it a little bit softer or something like that and make sure that I get it in. Alright? So it's kind of dependent on the situation. So this would probably be a dependent situation here. Now, if I hit it harder, I got a better chance probably of winning. Alright? If I hit it softer, then it kind of favors my opponent a little bit more. Alright? Make sense? Now, let's answer the question. Find the probability that the next time it's his turn to serve, he wins the point. How many different paths take me to winning a point?
3, 2.
2 paths. I'm going to multiply these together right here. So I'm going to do 3/5, or you could do 0.6 times 0.75. And I believe that is 0.45. Okay? You can verify that with a calculator. All right? Now, what's different about the second path to get a win?
You gotta go out, then in
Gotta
again.
go out, then in, then 0.45. So I'm gonna multiply all those together. Yes. I multiply the 2/5, the 3/4, the 0.45 all together. Okay? So 0.135. Now, I'm gonna take those two things and I'm gonna add those together. And so if I add those two things together, the probability that I win is 0.585. So 58.5%. So on more than half the points, I'm gonna win the point. Okay? It's not bad. Alright? Last thing. Given that he wins, alright? Given that he wins, what's the probability he wins? That right there, that's my given. It's gonna go on bottom. Alright? Given that he wins, what's the probability that he got his first serve in? Well, what's the path he got his first serve in?
In win.
At 0.45. So this is definitely a calculator problem.
Wait, where'd we get the 0.585?
That's the probability that he wins. So,
Okay.
given that he wins,
Okay.
okay? And then what's the probability he got the first serve in? That's the probability of the first serve.
Yeah.
Alright? This is like 0.76, something or other. Nine, I think.
0.67.
Okay?
76.
So there's a hat. Alright. We've got about 7 or 8 minutes left. Alright, the only question or the only problems tonight is, or until Monday, is the 385. Okay? So you're doing page 385.
Try to give us a nice weekend.
There you go.
We're trying to not try to give us